No, Cray. Jason Goodman works for Cray's Storage and Data Management Division, focused on product marketing and partnerships. Come August, Jason will have been with Cray for 3 years. Jason is more of a software guy than a hardware guy. He's worked for companies such as Microsoft, Polyserve, Isilon, and Aspera, among others as a freelancer. He studied history and journalism at Beloit College, rock on, I'm a music guy myself, and transformed a career as a laborer and freelance writer into high tech sometimes around 1994. On a personal note, Jason enjoys fiction writing, dog training, coaching youth lacrosse, and going to Lug in Miami and Denver too.
And more.
And more. I mean, you know, if you like pina coladas. No, sorry.
Why has it been a year?
I'm sorry?
Why has it been a year since we've seen each other?
Come to Bloomington. I mean, you know, we've got a Cray now. I'll buy you some donuts. I'll live vicariously through you.
And I'll buy you Leinenkugel. Leinenkugel?
No, I heard about it. Well, we need to buy another one. Ladies and gentlemen, Jason Goodman.
Thank you.
Pleasure.
Appreciate it. Yeah, so I'm kind of the marketing guy from Cray, who's here, you know, talk a little bit about Cray history, but also OpenSFS, and we're really on, you know, on this bandwagon of promoting OpenSFS. So we'll talk about that, and then I want to actually talk about Lustre in the context of our full stack, from, you know, the supercomputer all the way on down to tape archive, and then we'll just finish up with some questions. So one of my favorite quotes is from Seymour, and he really hit it on the nose when he said this. I mean, we're now doing things that we never thought we'd be doing, but it started back in '72, and one of the things that Cray is known for, besides shipping fantastic supercomputers and great customer services, giving our customers a case of Leinenkugel with each shipment. So Leinenkugel is the brewery in Chippewa Falls, right across from our manufacturing plants at Chippewa. They started in 1867, we started in '72. Now, according to a gentleman in Cray manufacturing, Randall Stansbury, who started with Cray in '81, he's not sure when the first shipment came in, but we think it was probably with the Cray one. When did Cray get into Lustre? We started with Lustre, and I'm curious if anyone was part of this in any way, shape, or form in 2004 with Red Storm at Los Alamos. Right, and that was no easy task. So the beer that I've assigned to Red Storm is the Red Ice beer that Chippewa started in '99. I thought it was quite applicable to that. It was, you know, a challenge, but we got it going, and we've been with Lustre ever since. And now we're actually doing, in partnership with Seagate, something called Synexion. That actually started back in, I think, more like 2011. But Synexion is essentially a Lustre appliance that we can talk a little bit about later. And that's really, you know, Bock beer. That's Bock beer. You need Bock. And there's also this technology that we've had since about 2007 called DVS. Some of you may know about it, but it's a key building block for us to both scale access to file systems like Lustre, and we're also using it in a new technology that we're calling data warp. So the future is seldom the same as the past. So we basically have 3 business units now, one fully focused on compute, both from high-end supercomputers down to more flexible, configurable clusters. We do storage, both in terms of Lustre, and we've got a system out called tiered adaptive storage, which gives you an archiving capability from Lustre, or even without Lustre, all the way down to deep tape archive. And we also have an analytics team that's doing both graph analytics and Hadoop appliances. And we're focused, we've historically been focused in the labs and academia. We're really making an emphasis now to move over to commercial markets. We've had a lot of success in oil and gas and other commercial markets. And what you don't see up there is where the analytics team is going, like Major League Baseball, there's some really amazing customers that we've got that aren't in part of those segments. So when we talk about storage from a Lustre perspective and what Cray brings to the table, it's really applying years of holistic systems expertise that comes out of supercomputing to Lustre. So at the very, it's not simply like most storage deployments where you roll in some storage system, turn it on, plug it in, deploy clients, and away you go. Lustre is a bit more complicated than that. And really what we've done is we've taken not just, a systems approach, but an ability to optimize the entire I/O path all the way up to applications. So that really comes from having deep knowledge of application workloads and being able to not only characterize those, but design systems that operate optimally end to end. So we're part of OpenSFS. We were a co-founder with others, and we're really committed to this. And just in terms of what role Cray plays, it's really about where the pie chart was shown with Intel developing all these features. Cray's role is really taking the Lustre tree, right? Taking our various versions of Lustre and validating those at scale and reporting back to both the user community and OpenSFS how they're doing. So it's really proving Lustre out at scale and making sure that all of the feedback that we have on it comes back in to OpenSFS. So one of the things I wanted to spend a few minutes about is a new program that OpenSFS is sponsoring. So if you are in the audience and your company is not a member of OpenSFS, we have a great opportunity for you to get on board for free for your first year. In other words, through OpenSFS, Cray is contributing $5,000 towards a membership. It can be of any level. It can be a starter, entry level, or it can be even a promoter level. So if you go to this, and I want to thank Jesse Kasman helping us really ramp this up for today and Lug and putting this together. So wait, is this thing telling me that I'm done? Should I just snooze it? If I haven't snoozed you already?
I didn't even realize it was there.
I'm like, wow, man. I thought I needed to be talking even faster. So Simsy, this is the perfect slide for you. I mean, we, as a collective group, we're really trying to get people involved in OpenSFS. And Cray really would like end users and customers involved. I know Brett at Intel is out there harvesting membership from many of the Intel resellers, which is wonderful, but we really want to get everybody involved. So literally today, if you can, feel free to sign up and then have a conversation with Steve about, whether or not it's a fit.
It's a fit.
All right.
If you're here, it's a fit.
So we hyper-focus sometimes on just Lustre, but when customers are deploying storage in Lustre, they're really deploying it in the context of workflows. And the workflows across many of those industries that you saw up on the board before are quite common. Doesn't matter what industry you're in, you're either acquiring, ingesting, or creating data. It's either coming in online or via tapes, or you're producing it someplace. And then it's got to be processed, stored, processed, and eventually you either do something with it, you either delete it, you put it on some intermediate storage, or you potentially even archive it. It could be on-site or off-site. And these three areas are really where we're focused. So with this TAS product, we've got an ability to let data live in a persistent context long-term for its lifespan, if you so choose, on disk or tape. For processing, we have Synexion and Lustre. And what's interesting about this is, some customers like Pawsey are acquiring their data right off the telescopes on the desert, and they're backhauling it directly onto Lustre. Other customers, you may be shipping a tape, and we could actually put it onto something like TAS. And then, part of our solutions, we ship solutions not just with Cray supercomputers, but our storage solutions work with pretty much any mainstream Linux OS cluster, CentOS, RHEL, SLES, and so forth. So one of the customers I wanted to talk about was Kaust. King Abdullah University of Science and Technology. It's really fascinating. So we're actually in the middle of an install here right now. And what this university does, it offers up their services not just to students, but some major corporations like Saudi Aramco. So they've got this industry partner program. Everybody is coming into the Takao supercomputing lab and actually using resources on that lab. So what they came to us for is really a version 2.0 of their supercomputing lab. They wanted to do soup to nuts replacement of their supercomputers. They had serious goals in terms of what the performance of those were going to be. Intermediate Lustre storage with a parallel file system, right? They wanted a comprehensive solution for that. And they also wanted some kind of archiving capability, but we're talking a pretty significant one, about 100 petabytes. So the solution that we're installing today is a combination of XC40 with a burst buffer technology embedded in it that we're calling data warp, Cray Synexion as the Lustre system, and TAS, which plumbs into Lustre through the HSM APIs, the Robinhood APIs, and actually then manages the data back on down to a SpectraLogic tape library. And the key thing about that is that there's full transparency between Lustre and that tape library, and you can have up to 3 intermediate tiers. So it gives them a lot of flexibility in terms of where the data is going to live. So I wanted to talk a little bit about, we talk a lot about Lustre, we talk quite a bit about storage and archiving, but we haven't talked too much about the future and trends and what Cray is doing on top of Lustre and other parallel file systems. And one of the trends that we see today, which is simply, we've gone from systems that included everything, CPUs, memory, and storage, to the detachment, the network attached storage world, which is on the far left, to now a world where we're actually separating memory from near and far and how applications deal with memory, but also storage. And this is really critical for a lot of our big customers, NERSC, Los Alamos, where we're actually in deployments and designing systems built on this future memory and storage off-node capability. So one of the products that we have in this space is called Data Warp. And essentially what Data Warp is, it builds on Cray's data virtualization services, or DVS, and extends that. So it's a software stack, and it's embedded into the system on blades, and those blades include SSD cards. And the real ability here is to do not only just a burst buffer use case capability, but to really offload peak performance from the underlying file system. And then if you do the cost analysis on that, instead of having to design your Lustre file system to handle peak, 2% of the time, you can actually trim it back and offload that peak performance up to SSD and flash. Key benefit here is that because Cray has this entire stack and we're doing all this in kernel mode, the system itself can be quite balanced and cohesive, from the applications and the tools that users use, from job scripts to workload managers, all the way down the stack to the storage. So one use case at Los Alamos is checkpoint restart, the ability to, if a job fails or stops for any reason, to quickly restart it on a massive system. So this is really, a way to, SSD provides a way to quickly write these checkpoints into memory and then trickle that information back down to disk and then restart as needed. And that, Gary has a quote in here about why that's significant for Los Alamos. But another thing to think here is that the use cases are really many. One is a simple fast scratch, meaning if you're working on a single node and your job needs very fast scratch, this will accommodate that. Another concept is the idea of global caching, where you actually want to be able to deliver global cache to multiple applications or an individual application is another use case. So I don't know how we're doing on time, but time for questions? Yeah, good. We get to lunch early. Any questions? Yeah.
Oh, does Data Warp have, that includes the software component then to move this burst buffer data storage?
It's an entire stack that essentially takes an underlying parallel file system like Lustre, projects it up to nodes on the supercomputer in various modes, and then through that you have these various use cases or benefits that you can take advantage of. And the Nirvana one is, which we're working on. We haven't delivered it yet. It's a roadmap item. Is transparent caching, where all applications can get some level of benefit from the flash storage. And then the Nirvana Plus is to be able to have quality of service to an individual application that says, I need some storage. It's got to be 0 latency, so many IOPS. Here it is, right? And it's provisioned in a job script. And then the other cool thing is that the tool sets that you're working with, whether it's like the native stuff that Cray provides on the system or third-party stuff that you should just work. So having that transparency is a big benefit. And that's lunch.
Jason Goodman, thank you.
You're welcome. Thank you.